Today let us start with a fresh topic that is nothing but determinants. Let us start with this topic that is nothing but determinants. So this determinants is related, we have already studied matrices, right? So this determinants is related to matrices. Means it has some relation with the matrices. In fact, you can say determinants is mostly related to square matrices. Right? So determinants, this topic is related to square matrices. Now what is this determinant, students? For every square matrix of order n, square matrix means what? Number of rows will be equal to number of columns, right? So you can say that if you consider a square matrix of order n cross n, you can simply say for every square matrix of order n, right? So for every square matrix of order n, there exists a number. That number may be a real number, complex number, or any number, and that number is called as determinant. I repeat, for every square matrix there exists a number. It may be real, complex, or any number, and that number is nothing but determinant. Now you may ask, what number, which number, from where does it come? Right? So let us study that today. Now with a number, I am focusing on the statement that determinant represents a number. Determinant represents a number. So, for every square matrix there exists a number. It may be real, complex, or any number, and that number is nothing but determinant. Means I want to say that my determinant is always a number. Suppose I consider a 2 cross 2 square matrix. Suppose I consider 2 cross 2 square matrix. So I hope you all know what is 2 cross 2 square matrix, right? It is a square matrix of order 2. So suppose we will consider this 2 cross 2 square matrix. Already what we know, students? We know that matrix is not a number, right? Matrix is nothing but an array. Matrix is nothing but array. When we add two matrices or subtract two matrices or multiply two matrices, the result will be again a matrix only. Right? The result will not be a number, or either the matrix will be a number. So what will be my matrix? Matrix will be nothing but an array. We know this. It is an array, and whenever you apply some operations with two matrices, the result will be again a matrix only. It doesn't turn out to be a number. But what did I tell you? I told that my determinant, it represents what? It represents a number. So there is a difference between these two, students. My matrix is an array, it is not a number. And whenever we operate two matrices, either by addition, subtraction, multiplication, or division, I will again get a matrix only, not a number. And this determinant, it represents a number. But if of this matrix we remove determinant, what we shall get? Suppose of this matrix is an array, right? And if we remove determinant of that matrix, we had considered the matrix 2 cross 2 square matrix. Suppose we remove the determinant of this matrix, we shall denote it by determinant of A. We shall denote it by two straight lines. It should be written in between two straight lines. So we shall denote determinant of A by like this, is equals to A, B, C, D. Here you can observe, students, matrices are written in square brackets. The elements of matrices are written in square brackets, but determinant is written in between two straight lines. It is written in between two straight lines. Right? So main purpose here is, I want to tell you all that determinant, when you remove the determinant of some matrix, the result will be a number. It may be any number. It may be real, complex, or any other number. Okay. So whenever you remove the determinant of a matrix, it will be a number. So each square matrix will have a determinant value, right? For every square matrix, we will be having a determinant. Now let us proceed further. We have two important things to remember. My first important thing is, when I write like this, when I write A in between two straight lines, this doesn't mean modulus of A. This doesn't mean modulus of A, students. Now is it clear? I think there is a network problem here. Is my voice clear now? Students, is my voice clear? Usma? Now just check it, students. Is the video clear and voice audible enough? Yes? Okay. Now what is my first important note, students? First important note is whenever I write this A set between two straight lines, that doesn't mean that modulus of A. In fact, it is called as determinant of the matrix A. Determinant of matrix A. Because modulus means we will write the numbers between two straight lines, right? Modulus of -2 means what is the purpose of modulus here? It makes all negative numbers as positive and all positive numbers remain the same. We all know this about modulus of numbers, right? So modulus of number will make the number positive if it is negative, and if it is positive, then it remains the same. But here, modulus of this group, this set is written between two straight lines. It means determinant of the set. Right? Please do not confuse it with modulus. Modulus is different. Modulus is for numbers. This here, with two straight lines between the set, is called as determinant of the matrix A. In fact, we can denote determinant also as determinant of A. We can denote determinant of the matrix A like this also, or like this also, or by single triangle. Right? So we can denote determinant in these three ways. We can write it like this also, determinant of matrix A, or we can write it between the two straight lines, or you can simply write it like this, a single triangle. So these three can be denoted as determinants. So this is the first important note. You do not confuse it with modulus of the set A. Okay? So this is determinant of matrix A. Second important note is we can remove the determinant of only square matrix. Determinants are only for square matrices. Very important, students. Determinants are removed only for square matrices. Only of square matrices we remove the determinants. So, in this whole topic, whenever I speak about matrices or whenever I speak about determinants of matrices, I will be always speaking about only square matrices, students. Is that clear? This is the second important note. Determinants are only removed above of square matrices. So, in this whole topic, we will be speaking only about square matrices. So, these two important notes you have to remember. Is that clear till here now? Any doubts, students? Any doubts? I hope it is clear till here. Now let us proceed further about to see what is the origin of this word determinants. Let us see what is the origin. Determinant. Origin. So in this, what we are going to study? We are going to study where this determinant word comes from. This determinant word, comes from the word determine. This determinant word comes from the word determine. So these determinants, these determine what do they determine, students? Determinant word comes from the word determine. And so what does this determine? These determine whether if the system of equations have unique solution or not. So before doing all the mathematical concepts about determinants, means how to find the determinants of matrices of various orders, first let us understand what purpose this determinant is having, students. So what does it determine? It determines if the system of equations have unique solution or not. Now you might be confused, students. First of all, I said that determinants represents a number. Now I am saying that it determines the system of equations. So how does this match? Remember, students, when we studied matrices, what we had studied? We had represented the system of linear equations. As in any system of linear equations, we would represent it by matrices. Right? When we studied matrices, we saw that if we have two linear equations, then we can solve it algebraically. But we had alternative method to solve it through matrices. Right? That is, any system of linear equations can be solved by matrices. So matrices we use to solve the system of linear equations. And here, this determinant helps us to see what type of solution that system of linear equation will have. I repeat, when we studied matrices, we saw that we were representing system of linear. Suppose we have given two linear system of linear equations, then we would represent it in the form of matrix and find the solution, right? Although we can find the solution algebraically also, but we can find the solution through matrices also. We can represent it through matrices and find the solutions of system of linear equation. So matrices were used to solve the system of linear equation, students. And here, this determinant helps us to find what type of solution that system of linear equation will have. I hope it is clear. What does this determine? Determinants determine. It determines if the system of equations will have unique solution or not. But matrices, how does it help us? It helped us by we just represented the linear equation, system of linear equations in form of matrices, and then we solved the matrices. Through that, we were able to find the solution of the system of linear equations, right? And determinants help us to find what type of solution that system of linear equation will have, whether it will have a unique solution or not. So is that clear to you all? So matrices, the one thing is clear. First of all, we know that matrices we use to solve the linear equations, system of linear equations, means to find the solutions of system of linear equations. So here, what does this determinant do? This determinant will help us what type of solutions that system of linear equations will have. Means whether it will have unique solution or infinitely many solution or no solution. That we can find by finding the determinant of the matrix. So now we have understood what is the main purpose of this topic, of this determinants. Right? Also we know that determinant word comes from the word determine. So it determines if the system of linear equations has unique solution or infinitely many solution or no solution. Is that clear? And hence this name determinant. So I hope we all know what is the origin of determinant now and also what is the purpose of this topic. Right? Purpose of the topic matrices was to find the solutions of linear equations. Though we have not done any example like that, we will represent the system of linear equations in form of matrices, solve the two matrices, get the answers, and that answers will be nothing but solutions of those two system of linear equations, right? And here this determinant will help us to tell what solution, what type of solution, means if we get solution, what type of solution you will be having for the system of linear equation. Whether you have unique solution or infinitely many solution or no solution. And hence this word comes as determinant. Is it clear to everyone? Is it clear, students? Yes? Any doubts till here? If you have any doubts, then you can just let me know. I hope you have well understood why does we use these determinants. So why does we use these determinants? Can anyone tell me now? What is the purpose of these determinants? Why we have to study these determinants? Yes, anyone? I want to know how much you have understood. Why we have to study this topic determinant, students? What does it determine? Yes? Any answer? So why do we study this determinant? I want answer from you all. What is the purpose of this topic determinant? Please, whenever you will be studying any mathematics topic, first try to understand what is the purpose of the topic. Means why we need to study that topic. If you understand that, then you can understand the whole topic very clearly, students. Matrices why we studied? We studied it to solve. It helped us to solve the system of linear equations. It helped us to solve system of linear equations. In other way, it helps us to find the solutions of system of linear equations. So matrices, what does it do? It helps us to find the solutions of system of linear equations. Uzma, to solve the solutions related to matrices. See here, to solve the solutions related to matrices is the work of matrices, not determinants. Matrices helps us to find the solutions of system of linear equations. What does determinant do? Yes, tell me, what does determinant do? Matrices will help us to find the solutions of system of linear equations. What does this determinant do? Yes. What does this determinant do? Yes, students? This determinant will help us to know the nature of solutions. This determinant will help us to know what? It helps us to know the nature of solutions. Means whether it has unique solution, whether the system of equation has unique solution, or infinitely many solution, or no solution. So what does this determinant do, students? It helps us to know the nature of solution. Means what type of solution the system of linear equations will be having. Whether it will have unique solution or many solution, infinitely many solution, or no solution. So the purpose of these two topics, I hope it is clear. This matrices will help us to find the solutions of linear equations, and the determinants are used to find the nature of the solutions, whether it is unique, infinitely many, or no solution. Is that clear now? The purpose of both these topics? Yes? Is it clear, students? Okay. Now, let us go back to our 10th standard. 10th standard topic linear equations in two variables. Okay. So let us revise, remember what all we have studied it there. Suppose we consider two system of linear equations in two variables. Suppose we consider system of linear equations in two variables. Let me take one equation, one linear equation as a1x plus b1y is equals to c1, a2x plus b2y is equals to c2. I hope you all remember what do we mean by linear equations in two variables. Right? So I hope you all remember that. Here you can observe two variables are x and y, and these all are real numbers a1, b1, c1, b2, b2, c2. So these are my two linear equations in two variables. Now what we have studied in 10th standard students? We have studied three concepts here. First concept, if a1 by a2 is equal to b1 by b2. If a1 by a2 is not equal to b1 by b2, then the system will have unique solution. I'll just write it down. You please remember till then whether we had studied or not. Second one, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the system will have many solutions. The system will have many solutions. And third, what we studied, if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then the system will have no solution. Have you all studied these students about linear equations in two variables from the 10th standard? Do you all remember this? Yes? Yes, right? We have studied this. If we consider two linear equations in two variables, then with the coefficients of these variables, we can determine some things. What do we determine? First one is if a1 by a2 is not equal to b1 by b2, then this system of equations will have unique solution. Second one, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then this system of linear equation will have infinitely many solutions. Next, if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then the system of linear equation will have no solution. So these things we already studied in algebra, right? So here also we are going to do the same thing. First we will represent the system of linear equations in the form of matrices. There comes the picture of the whole topic matrices. We all know we know everything about the topic matrices. Then what we will do, students? We will determine the determinant value of that matrix. So what does that determinant value tell us? It tells us whether the system of linear equations will have unique solution or no solution or infinitely many solution. So similarly like this, here we are going to study what type of solution does the system of linear equation will possess. Right? Now, if I consider this first case where the system of linear equations will have unique solution. Okay, so if we consider this first case, I can write this in either way as cross multiply. If we cross multiply, what I get? a1 b2 is not equal to a2 b2. I can write it like this also, right? Also, I can write it as a1 b2 minus a2 b1 is not equal to 0. So I can write it like this also. We have just took this term on the other side. Right, so how I can write this? I can write it either as a1 b2 minus a2 b2. This is actually, students, this is actually determinant value. This is actually determinant. How? Let us see. See here. Let us see how this is my determinant value. Now Now suppose I want to write this system of linear equations in the form of matrices. So how shall we write? How shall we write, students? I will write it as a1 b1 a2 b2 x y c1 c2. So here these coefficients of variables I am writing in one square matrix. This is 2 cross 2 matrix, right? Next, variables I am writing one column matrix, one different matrix. That will be equal to C1 and C2, right? So C1 and C2 constant terms I will write it on in one matrix. So I can represent the system of linear equations in form of matrix, right? So here you can see my matrix A is nothing but A1 B1 A2 B2. It consists of all the elements, means it consists of coefficients of the variables. So here my matrix A is nothing but A1 B1 and A2 B2. So what does this determine, students? A1 B2 minus A2 B1 will tell me whether the system of linear equation will have unique solution or not. How? Already we saw in 10th standard algebra, if A1 by A2 is not equal to B1 by B2, then system of linear equations will have unique solution. Right? So here you can see, if I simplified that, we got this A1 B2 minus A2 B1 is not equal to 0. Now here, if I write the system of linear equation in form of matrix, here what will be my matrix A? Matrix A is equal to A1 B2 B1 A2 B2. Now if I find this A1 B2 minus A2 B1, A1 B2 minus A2 B1, and if this turns out to be not equal to 0, then you can conclude that the system of linear equations will have unique solution. So like this, we will represent the system of linear equations in form of matrices, and then we shall remove the determinant of this matrix A, which tells us whether the solution will be unique or not. This was just a simple example. So if you consider two system of linear equations in two variables, what did we see? From 10th standard we know everything, right? If A1 by A2 is not equal to B1 by B2, then the system has unique solution. So if I simplified that, I got this I1 B2 minus A2 B1 is not equal to 0. If this happens, then the system will have unique solution. Now if we write the system of linear equation in form of matrices, here my matrix A will be A1 B1 A2 B2. And from this matrix A, if we remove A1 B2 and minus A2 B1, if you have found out this, and if this turns out to be not equal to 0, then what you will conclude? You will conclude that the system of linear equations will have unique solution. The system of linear equations will have unique solution. And this is nothing but my determinant of A. This is nothing but my determinant of A. You can denote it in either way. You can either denote it like this, or you can simply write a triangle. It's your wish, students. Okay, so this is nothing but what? My determinant of matrix A. I hope till now everything is clear, students. If you are very well perfect with the concepts, basic concepts from 9th and 10th, it will be very easy for you all to understand the concepts from P2. So if you know the linear equations in two variables very well, this concept must be clear to you all now. I hope it is clear to everyone. So like this we will understand what type of solution the system of linear equation possesses, students. So you saw we represented the system of linear equations in form of matrix. Here we got the matrix A, and if you are able to find this A1 B2 minus A2 B1, and if it is not equal to 0, then the solution will be unique. So are all things clear now? Everyone? Is it clear till here? Do you have any doubts? If anyone is having doubt, then please let me know right now. Directly, I am not going to start how to find the matrices, determinants of the matrices students, because I want you all to understand what is the purpose of this determinants and originally where it comes from. Originally, matrices and determinants come from this linear equations in two variables only. You can see here. We represented the system of linear equations in form of matrices, right? And from this matrix A, if you find the determinant value, you will get to know what type of solution the system of linear equation will possess. Only that is the thing. So these things must and should be clear to you. Okay. So no one has any doubt? Let us proceed further. Now let us see how to find the determinants of matrices of particular orders. As I already told you, whenever I speak of matrices in this whole chapter, I will be speaking only of square matrices students. Please remember, only of square matrices. So now first of all, let us find determinant of matrix. Matrix is different of square matrix of order 1. Of order 1. So first of all, let us see how to find the determinant of matrix of order 1. So matrix of order 1, how does it look like? It contains only single element, right? This is 1 cross 1. So this is a square matrix. In fact, it is a matrix of order 1. So how many elements are there in this matrix of order 1? Of course, there will be only one element. And to remove the determinant of this matrix of order 1, it will be the same element. But here, you will not write it in terms of brackets. It will be a number. Please see students. Matrix of order 1, it is very, very important. Matrix of order 1, you will write it in square bracket. And when you remove the determinant of matrix of order 1 will be the same element, which will be a single element, right? That element will be only the determinant of the matrix. And here you write it as a number. You will not write it in square brackets. Suppose my matrix A is equal to minus 6. My matrix A is equal to minus 6. Suppose my matrix B is minus 6. Means it is a square matrix of order 1 cross 1. It is a square matrix of order 1. Can you tell me what will be the determinant? Yes, what will be the determinant of matrix B, students? Minus 6, very good. It will be nothing but that single element from the 1 cross 1 square matrix. Right? So it will be minus 6. So whenever you have to find the determinant of matrix of order 1, in matrix of order 1 we will be having only single element. You will write it in square bracket. But while writing the determinant of that matrix, answer will be that same element but without the matrix. So is that clear? This is how to find the determinant of matrix of order 1. Now if we want to find the determinant of matrix of order 2, again I am speaking only of square matrices. So if we want to find the determinant of matrix of order 2, let us take matrix of order 2. I hope you all remember the general representation of the matrix, right? So generally we will represent a 2 cross 2 square matrix like this. I hope you all remember that, right? So what will be the determinant of this matrix, students? Determinant of this matrix A will be equal to, you will write it between two straight lines. So what you will do here is, you will multiply this 2 and then subtract it from this. Means A11 into A22, A11 into A22 minus A12 into A21. A11 into A22 minus A12 into A21. Before, when we had considered the system of linear equations, there also what did I say? Determinant of A. What does this determinant of imply A1 B2 minus A2 B1, right? A1 B2 minus B1 A2. That is A2 B1. Here also it is the same. First you multiply these two, A11, A1, A2 minus A12 into A2. So 2 cross 2 square matrix, you will find determinant like this. Cross multiply and subtract. First you multiply these two minus, then you multiply these two. Right? So can you find what is, suppose we will take some example. I hope this you understand how to find the determinant of matrix of order 2. So first you multiply these two minus, then you multiply these two. So suppose I gave you two matrices. So what is the determinant of this 2 cross 2 square matrix, students? 2, 4, 5, 1. Determinant is represented by two straight lines. Okay, so tell me what is the determinant?